I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer eClub's Ask the Cook. Since we're in the kitchen, we're going to talk about the refrigerator. It's a PolymerFEST. There's a number of different polymers and a number of different processes to be seen there, so let's take a look. This should give you some insights to knowing how to design parts for various applications and the types of processes that are available to you. Now, what is a refrigerator? Well, it's an insulated box. Back in the 1920s, when refrigerators were new, it was two freestanding boxes, one inside the other, with a stack of insulating material in between. Such things as cork were used in the early days because it was cheap and because it was a decent insulator. As these devices got more sophisticated and there were more of them, you had to have materials that were easier to work with and that had better insulation properties. And so over time you had things like fiberglass, even polystyrene foam in its early days. But the real innovation came when polyurethane foam came. And let's pay attention to what that enabled. Because now you have an insulating material that's also the glue that holds the whole system together. So instead of two freestanding boxes with all the stiffness and material usage of that, you have a relatively thin wall of metal on the outside, a relatively thin wall of plastic on the inside, bridged between with polyurethane foam as the insulator and primary structural element, holding these two very thin materials together and making a refrigerator. So the materials, how would you make a part like that? Right, you got this relatively big tub of a shape with details on the sides to help you with shelves and drawers and so forth. How do you make a part like that? And it's very interesting to think about large parts that are thin-walled as having a one-sided mold, not two-sided where you have to flow the plastic in between, but single-sided, so you simply touch this sheet of material to it and freeze the shape. That's called thermoforming in this case. It can be twin sheet forming. There's also rotational molding, which we'll talk about later in another episode. But thermoforming is used to make these liners. And with thermoforming, you simply freeze the material to the liner and then you can pop it out. The cycle times are short, the walls are thin, and this is a place where you have to have melt strength. That is, the polymer, when it heats up, can sag a little bit, but you don't want it turning to a liquid and falling onto the mold. It won't make nice parts if you do that. So this is the place where the traditional semi-crystalline materials are out. There are some semi-crystalline materials that can do this, that have some melt strength, but their surfaces are generally soft, so they're very difficult to clean without scratching, and so they probably don't belong in this application. What is usually here are the amorphous polymers for their harder surfaces, and ABS is the king. ABS because the acrylonitrile gives this thing a little stiffer surface, a little shinier surface, and it gives it a little bit more melt strength, making it easier to form very thin, very uniform liners to make high quality refrigerators. So you'll see that. Also, acrylonitrile gives the product a slightly more solvent resistant, so it's resistant to cleaners, making it a little easier to clean and keep the color and shape. There are lots of polymer processes to explore in the refrigerator, and we will do more. But knowing what resins and processes are good for making large parts, that's working knowledge. That's what you get from us here, Polymer eClub Ask the Cook. Don't forget to subscribe, like, and share if you appreciate the content. You can follow a link in the description to learn more about the Polymer eClub and how to get involved. I'm Todd Cook for Polymer eClub Ask the Cook. Thanks for watching.